Okay, what I'm going to try to do is I've been asked to explain how the derivative of the volume of a sphere matches up and arrives at the formula for the surface area of a sphere. The volume of a sphere, remember, is 4 over 3 pi r cubed, and when you differentiate that you get 4 pi r squared, which happens to be the exact surface area formula for a sphere. So how are they related? How do you differentiate this volume and then end up with the surface area? Well, let's imagine this. Imagine I've got this sphere right here. Well, let's imagine this is a gigantic sphere, say a radius of say 10,000 centimeters. So imagine it's huge. Now let's say that radius increases by say 1 centimeter. As that radius increases by 1 centimeter, it's very incrementally small compared to the original radius of 10,000 centimeters. Now, it's almost like I've got this very, very large radius, but compared to the amount that I'm adding onto it, if I increase by 1 centimeter, it's almost like I'm putting a very, very small extra amount onto that radius, a small increment. We might even call it delta r, using our calculus terminology. So as that increases, I want you to think of it this way. Let's imagine this is a very, very large radius, and as I put on this incrementally small extra amount to the radius, the volume increases slightly. In fact, it increases, think of it this way. Let's imagine as the volume increases, as I make that radius incrementally small increase in it, it's almost like, if you could imagine, I walk along and I paint it, and I put on a coat of paint, a layer of paint all on it. Well, that thin layer of paint is a very small increase in the volume. In fact, it's so small, it's almost negligible, but it's so small, yet it's an increase in the radius, and it's therefore an increase in the volume. But I've put on a layer of paint. Now that layer of paint, as I said, represents an increase in the volume, and the increase in the volume is in fact equal to a layer of paint, which is the surface area of the sphere. So as the sphere's volume increases in an incrementally small manner, which is what calculus is about, looking at the limits as things approaches a small number or zero, as that volume increases with the radius increased in an incrementally small way, the volume in fact increases by grabbing and getting an extra surface area on it, a 4 pi r squared on it. So the volume formula, 4 over 3 pi r cubed, increases slightly as the radius increases with an extra layer on it to make the volume bigger, and in fact it increases by 4 pi r squared. Hence, in conclusion, the rate at which volume changes of a sphere's volume is equal to the surface area of the sphere. Amazing, isn't it?